So what I'm going to talk about today is redox, the term redox. So what does redox mean? It's a concatenation. That means it's a word that's made of two words that have been joined together. The red part of it is reduction, and the ox part of it is oxidation. So there's two ways to describe oxidation and reduction reactions, and the first one is in terms of oxygen and hydrogen. So if we look at if we describe them in terms of oxygen and hydrogen. So if something gains oxygen, so if it gains oxygen, we call it oxidation. So it gains oxygen. Okay, if something loses oxygen, we call it reduction. So if we lose oxygen, it's called reduction. Okay, I'll just separate those. Now if we describe it in terms of hydrogen then, so if something gains hydrogen, we call it reduction. Gains hydrogen. Can we see that? Yeah. So conversely, if it loses hydrogen, it's oxidation. Okay, so that's a simple way of describing oxidation and reduction, and that's absolutely fine for very simple chemical reactions where you can actually see that oxygen's been lost or oxygen is being gained, or hydrogen's been lost or hydrogen's being gained. But not all reactions have oxygen or hydrogen in them, and displacement reactions is one of them. So we have another way of describing reduction and oxidation, and we describe it more generically in terms of electrons, and it's a much better way of describing oxidation and reduction, because the losing and gaining oxygen and hydrogen also fit into this this explanation as well. So if something if we've got gain of electrons, then it's going to be called reduction. So gain of electrons. So if our substance gains electrons, we'll say it's reduced, and if it loses electrons, it's going to be oxidized. So we get this term oil rig. So oil is the oxidation is loss of electrons, and the rig is reduction is gain of electrons. I'll see if I can show this in a little bit more detail. Okay, so let's consider the reaction of magnesium burning in oxygen. Now magnesium burns in oxygen and it will make magnesium oxide. So we can see that the magnesium has gained oxygen. So in the very simple sense of the word, the magnesium's oxidized because it's gained oxygen. But we can also show that we've actually got a reduction process occurring, which we wouldn't be able to see if this was the only way that we could describe oxidation or reduction. We need to look at the electrons, and we can do that quite simply. I'll show you as an atom model. So here we've got a model of the magnesium atom and the oxygen atom. So magnesium atom, when we use the periodic table, we can see it's got 12 protons and so 12 electrons in its outside shell. So the protons are in the centre, it's the electrons we're interested in. So when we put the electrons in their shells, 2 sit in the inside shell, 8 sit in the next shell, and 2 sit in the outside shell. And with oxygen, oxygen only has 8 electrons. It has 8 protons, so 8 electrons. So 2 are in the inside shell and 6 are in the outside shell. Now, what do we know about atoms? They want a full shell of electrons. So magnesium is a metal. Is it easier for it to gain 6 electrons to fill this shell or lose 2 electrons? It's easier for it to lose 2 electrons, so it will lose 2 electrons. So I can write the fact that it's losing 2 electrons. So the magnesium will become a magnesium ion, and because it's lost 2 negative charges, it'll be a 2 plus ion. How do I know that? It's got 10 protons, 10 positive charges in its nucleus. At the moment it's got 10 negative electrons around the outside, but if it loses 2 electrons it will only have 8 electrons. So it's got 10 protons and 8 electrons, so 10 positive charges and 8 negative charges. So overall it's going to be positively charged. See if I can show that a bit better. Okay, so the magnesium becomes a magnesium 2 plus charge, and there's the 2 electrons that it's lost, and I'm going to just represent them as these green electrons. So the electrons move, they will go. Oxygen has 6 electrons in its outside shell. Is it easier for it to gain 2 electrons to become 8, or is it easier for it to, I just pause this. Or is it easier for it to gain 2 electrons, lose 6 or gain 2? Well, it's easier for it to gain 2. So these 2 electrons from magnesium are going to go into the shell of the oxygen atom. Okay, so I can show that. I'll do it in a different colour so we can see it. So the oxygen atom actually gains those 2 electrons from magnesium, and because it's got 2 more negative charges than it had originally, it's a 2 minus charge. Now if I so this was my magnesium atom, and my magnesium ion is now this, and my oxygen atom is now this. Okay, I'll do it a different way so you can see that again. Okay, so I'm just showing the outside electrons now. So this is magnesium atom with its 2 electrons in its outside shell, and it's going to lose those 2 electrons. So here are the 2 electrons. I'll take them off. So there's 2 electrons, and they're both negatively charged, and we're left with our magnesium ion, which now has a 2 plus charge. So that's our magnesium ion with its 2 plus charge, and there are the 2 electrons. And I can write this as magnesium, that's that magnesium atom, goes to the magnesium 2 plus charge plus, oh, and there's the 2 electrons. Okay, so we've got the 2 electrons there already. So that's my first equation. That's telling me what the magnesium does. So the magnesium is losing electrons to become a magnesium 2 plus ion. So what's oxygen doing? So oxygen is going to gain those 2 electrons, and those 2 electrons are going to go here and pair in here, and it's going to give me an oxygen ion. 1, 2, 3, 4, 5, 6. It's going to have a 2 minus charge. So how can I write that? So that's an oxygen atom gaining 2 electrons to give an oxygen, oxygen ion. Okay, so again, I've managed to write that out. So oxygen gains 2 electrons. Oops, it shouldn't be like that. It should be as I did it before, O2 minus. That's the oxygen ion. Okay. Okay, so I've just rewritten those two equations again that have got the electrons in. And because they've got the electrons in, we call these half equations. Okay, so they're half equations. So magnesium atom goes to a magnesium ion and 2 electrons. Those 2 electrons are captured by the oxygen. So oxygen captures those 2 electrons and becomes an oxygen ion. Okay, so if we go back to our definition of oxidation and reduction, so oxidation is the loss of electrons. Okay, so which one of those has lost electrons? It is the magnesium. So this is the oxidation reaction because the magnesium atom has lost the electrons. Okay, so let's look at the rig part of this. So reduction is the gain of electrons. So which one of these has gained the electrons? Well, it's the oxygen. The oxygen has gained the electrons. So this is the reduction part of the half equation. So you will always get one half equation as one atom or molecule that is oxidized, and there will always be something that's been reduced. So these are our two half equations. They include electrons. Okay, so now I'm introducing the concept of just using ions. So we can show this as ions. So what I can do is I can split my reaction in half, and on this side I'm only going to put my reactants, and on this side I'm only going to put my products. So this, I reacted magnesium with oxygen. My magnesium lost, my oxygen gained 2 electrons. I made magnesium 2+ ions, and they were the 2 electrons that it lost, and an oxygen ion. Okay, we can see that these electrons are the same as those electrons because the magnesium lost its electrons and the oxygen gained it. So in my equation, these electrons cancel out. Just like a numerical equation, I could rearrange it and put these electrons on this side of the equation. So if I move these to this side of the equation, the plus sign becomes a minus sign. So I can take those away. And then what have I got? I've got plus 2 electrons, take away 2 electrons. So they actually cancel out. So now I'm left with what I would call an ionic equation. Okay, so this is my ionic equation because it just contains ions. Okay, so here's another example. So one of the questions asked in the lesson was, how do you know what the charges are on the ions? How do you know they're a 2+ or a 1- charge? Well, some of that is because you would use your periodic table. Another one is you would know, and you might be given some information, like I've been given this information that the sulfate ion has a 2- charge. Now we know that this compound, this copper sulfate compound, is neutral, and so because it's neutral, then we can work out the copper charge. So if we split it in two, so we know this sulfate has a 2- charge, So the copper must have a 2 plus charge. So it must be copper 2 plus. Let's look at the zinc. And we split the zinc sulfate in half. Zinc sulfate has no charge. It's a neutral compound, but we know that the sulfate ion part of it is 2 minus. So the zinc part of it must be 2 plus. Okay, so that's given us some information. Now what we're looking at, we want to see how the zinc changes in this equation, and then how the copper changes in this equation. So this is why they're called half equations, because we're only looking at half the equation. We're only looking at half the reaction. So we can see that the zinc goes from an atom and it goes to a zinc 2 plus ion. And how does it do that? It must lose electrons. Okay, so the electrons come off the zinc, and there's our 2 electrons that come off. So I'm going to call them 2 electrons. I'm going to do it that way. Okay, so they're the 2 electrons that come off. And then let's have a look at what happens to the copper. So on the reactants part, we've got a copper 2 plus ion, and it goes to a copper atom. How does it do that? Well, it must capture 2 electrons. It captures these 2 electrons that zinc has let go. So these are the 2 electrons from zinc. So the copper ion collects the 2 electrons from zinc and becomes copper. So there are 2 half equations. Now what I can do is I can add them together to find the ionic equation. So we've used the full equation to give us 2 half equations, and then we use the 2 half equations to give us the ionic equation, the one that only contains the things that change. So I'm going to keep everything on the reactant side of the arrow on the reactants, and everything on the product side of the arrow on the products. So I've actually got zinc and a copper 2 plus ion and 2 electrons on the reactant side. On the product side, I've got a zinc 2 plus ion plus a copper atom plus 2 electrons. Okay, so now I can simplify that because I've got plus 2 electrons on each side. So the electrons that the copper released, sorry, the zinc released, the copper picked up, but it's plus 2 electrons, plus 2 electrons. If I took this to the other side, just like a mathematical equation, that would become minus 2 electrons. So these actually cancel out. So my overall equation, my overall ionic equation, is zinc plus copper 2 plus gives zinc 2 plus plus copper. So the zinc is displacing the copper from the copper compound. It's becoming a zinc compound, and copper becomes a metal. Because zinc's a metal here, copper's the metal there. So we've got displacements. Now can we work out which one's oxidation and reduction? Oxidation is loss of electrons, and the zinc has lost the electrons, because look, there they are, the zinc's lost them. So this is oxidation. And which one's reduction? Reduction is gain of electrons. The copper ion has gained electrons, so this is the reduction. So altogether, we've got our redox reaction. So a redox reaction is an oxidation and reduction reaction using 2 half equations, which we can get from the full overall equation by looking at what's changing and just using that element to show, and then we can put them together to get an ionic equation where we can show just which species were changed. I didn't include the sulfate because the sulfate is the salt. I've got a copper sulfate salt, I've got a zinc sulfate salt. The sulfate didn't change, all it did was change its partners. So the sulfate's not part of this because it didn't undergo any chemical reaction whatsoever. It's still there, and we call those ions that don't take part in the chemical reaction, they just hang around, we call them spectator ions. Spectator ions. And that's the sulfate ion. It's a spectator because It's there at the beginning as copper sulfate, it's there at the end as zinc sulfate, so it's just spectating, it's not losing or gaining electrons. Hopefully that's helped you. It's a little bit longer than I was expecting, but I hope that that's been a better explanation.